Okay, trapezoidal rule's a lot like Riemann sums, except for instead of doing rectangles, we're going to do trapezoids because it gives us a better approximation. So you're still cutting it up into however many sections they tell you to, but instead of going left endpoints and drawing this over as a rectangle, you're connecting those two pieces that hit on the graph. So looking at this first trapezoid, is it an over or an underestimate? It's under, not by a lot, but it's under, right? The next one here is a little bit over, this one's a little over, this one's a little under. So it gives you a decent approximation a lot of times. Obviously, it depends on what your graph looks like. So let's go ahead and we could use this formula here. I just find that the formula doesn't work a lot of times on the way the AP test asks the questions. So I just think of finding the area of trapezoids. So we should always have the formula for area of trapezoids in our pocket here because that'll help you. Does anyone remember how to find the area of a trapezoid? Okay, it's close. So instead of subtracting, we're going to add our bases together. Yeah, so if I do this, I'm averaging my bases, right? So I'm taking this base here and this base here, and I'm averaging them, which would bring this one down a little, bring this one up a little. And do you see how that makes sense for the rectangle? Then you have to times it by your height, right? So it's kind of making that trapezoid into a rectangle that you could do. So average your bases times by your height. That's really the thing. If you know that, you should be able to do all the questions on the AP test. Here, this is a formula that works, so we'll look at it too, because sometimes it's quicker to do the formula. It just, I would say more times than not, knowing this will help you more on the AP test than like the formula will. So you do your change in x, so how much your x is changing by down here, divided by 2, and then you leave the front one alone, you leave the back one alone, so you'd leave this value alone, and you'd leave this value alone, and then you take all these values in between times 2, and you add all those together. It gives you the same answer as finding the area of each of those trapezoids and adding them up. Okay, so page 540, number 1, I think it's asking us to use a trapezoidal rule with 2, but let me just double check here. Okay, so 540, number 1, you're going to need it for the picture. So go ahead and open to that. It says, let I equal the integral from 0 to 4, and we're given a graph from 0 to 4, where f is the function whose graph is shown. Use the graph to estimate L2, R2, and M2. We're going to skip that part. Are these underestimates or overestimates? That was from the last section. Now we're going to do part C. And we're going to use the graph to find t sub 2. So what does the t tell me and what does the 2 tell me? Trapezoidal and 2 trapezoids we're cutting it into. Okay, so if we're trying to use the formula, what is our change in x if we're having 2 trapezoids from 0 to 4? 2. Okay, so we'll write it out as 2 and then divide it by the 2. You're always dividing by 2 there. And then you'll leave the first piece and the last piece alone, and then the middle piece, or middle pieces, if there's more, you multiply by 2. Okay, so if it's a trapezoid, if there's 2 trapezoids, you should have 3 values in here. Okay, it should always be 1 more than how many values you have. So looking at the graph, what is the value at 0? 0.5. What is the value at 2? 2.5. And what's the value at 4? 3.5. So this is how you would use that rule. So we just have 5, 6, 7, 8, 9. Look right. And then it tells us to write whether, I think it does, how does it compare with I, so whether it's an under or an overestimate. So if our graph is looking kind of like this, I exaggerated it slightly, but it's a concave down one, and I draw trapezoids that go from here to here, and then from here to here. Is it over or under? Under. So then we would say that our t sub 2 is less than I. And usually I would say they'd probably ask whether it's an over or an underestimate and not have you compare it, but you never know what they're going to do. So any questions on that one? Could we do it with a formula here instead? Yes, we could, right? So we will actually do the last example using this instead of the actual formula. And then part D, it's saying list the numbers, your left, your right, your midpoint, your trapezoids, and I in increasing order. I think we're okay with that because we kind of talked about that before. So let's go ahead and try this one here because some people make these problems harder than they have to be, or they mess up where their actual spots are here. So we're going from 1 to 2. I find drawing a number line helps people who have trouble with this. Okay, so we're going from 1 to 2. How many am I trying to split this into? 10. Okay, so we should have a 1.5 here, and it should just go by 1/10, right? It's okay if they're not evenly spaced. Okay, so we got our 10 chunks here. We're going to draw trapezoids within each of those. And we're going to use our calculator to help us with these. But these ones just require a lot of writing. They probably wouldn't have it be 10 on the AP test if we were doing this. So. Okay, so if we're using the trapezoidal rule, and let's say we're using the formula, I'm going to write t sub 10 because I have 10 of them. What number goes on top for my change in x? How much are my x's changing by? 0.1. And you can do b minus a, like if you look back here, you can do your b minus a over n, and that'll give you the same thing. So if you do b minus a over n, that would be 2 minus 1 over 10. So do you see how that's 1/10? So if you're having trouble with it because it's a weird interval or something, maybe there's a pi in there, you can always use this to find your change in x. And then we're dividing by what all the time? 2. And then we're going to find the function value at what first? At 1. The very last one should be the function value at 2. And then everything in between, we should have 2 times it, right? So we're going to do 2 times the function at what? 1.1, 2 times the function at 1.2, dot, 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 plus 2 times the function at, what's the very last one before this? 1.9, and then plus f of 2. So let's talk about how we do this in our calculator, at least more quickly than what it would take. So get your calculator. What would I put in my y equals? Whatever's in here, good. So in your y equals, that's what you're going to throw in there. So we've got square root of x cubed minus 1. Make sure it's all underneath that square root. And then I would look at what, do you think? Table, what would I start at? 1 and go by 0.1s. And then it gives you all of those values to pull from. Now, when you're doing this, if this is an AP, like an actual AP test question, your answer has to be correct to how many spots? 3. Your answer has to be correct to 3 spots. That doesn't mean like as you're going you want to round to 3 spots. So you're going to use all these values here. These middle ones all here, you're going to multiply by 2. The outside ones you're just going to leave the way they are. Add all those together. Make sure you remember to multiply by this. That's actually one of the things that people forget to do. They might write it here and then they forget to apply that to their answer. but people often take this problem and make it way more difficult than it has to be. You don't want to round these to 3 decimal spots though. I would say try to round them out further. In your homework it's not a huge deal, but on the AP test it is a huge deal. So you could always scroll over the top of this. If you scroll over the top of your Y value, it actually gives you more values there than what you needed, okay? So here you're only seeing 5 decimal spots, but let's say you're just trying to be more accurate and you want more decimal spots, or maybe it was like 126 point something, you don't see very many decimal spots, you can just scroll over the top of those Y values to find more decimals if you need them, okay? So does everyone understand how to finish this problem? Okay, so let's move to the next one. I think the answer is like 1.506, but let's go to the back one because this one's more AP-like than any of those other ones, I would say. Okay, it says a radar gun was used to record the speed of a runner during the first 5 seconds of a race. Estimate the distance the runner covered. Use the trapezoidal rule. So if we're trying to find the distance that they covered, our label should end up being what? Meters. So double check the labels here. If I take meters per second times seconds, do I get meters here? Yeah, because sometimes those seconds, sometimes 1 second, one's minutes, so you actually have to look at changing that before you start the problem. So if we're using the trapezoidal rule, sometimes it helps to sketch it. So if it helps you to sketch it, that's fine. What is the base of the first trapezoid going to be if we start at 0, 0, and then go to 1 and 7.34? 1, right? And then you have to average your bases. So for the first one, your bases are 0 and what? 7.34. Dividing it by 2, and then multiplying by 1. And I would write all of that because it's going to help you when you move on through here, especially if you're looking back at your notes. Okay, the next one here goes from 1 to 2.1. I'm just going to write it like that here so it's easy to see. And it's a little bit higher here at 9.73. So what do I put in that big parenthesis?
7.34 plus 9.73 divided by 2 times 1.1.
Times the 1.1. Okay, and this is a very AP-like question. They like to switch that interval, which kind of throws that formula out the window anyway. Okay, so then the next one, so we did from here to here already. We just did from here to here. So the next one would go with these two values, 9.73 and 10.51. And I'm going to actually have you guys do this one out, so if you're ahead of me, that's fine. You can use your calculator. And the width of that one would be did you guys get 0.9 for that width? I think you're just ahead of me. Okay, so I'm just going to continue up here and you guys can check. Make sure you have your setup right. Okay, and then when you get your answer, share it here so we can check it.
You have to do one. No, never mind.
Get them all. And a way to double check that you got them all is just check that these numbers here are matching. You know, this should say 7.34, it should repeat. This should say 9.73, it should repeat. We got a 10.51, it should repeat. Because it's easy to miss one there. Double check your widths if you have time to do that for sure. And whenever you see a table of data, do not make up data, okay? Do not go, okay, I'm going to look in between and look at 0.5 and try to make up a velocity for that. We don't know what it is. If you ever make up data in a table on the AP test, you're going to get it wrong. So just, there's no point in doing it. Anyone get like 43 point something? What did we get? 43.6015. And you can write it like that. What they do if you write more than 3 decimal spots is they only look at the first 3 decimal spots. So this answer's fine. Or you can round it. So 43.602. So either of these answers gets you the answer point on the AP test. This is called truncating it, and this is obviously rounding it there. So. No, 43.601 is fine because they truncate it. Yeah, so that is completely fine. You can either truncate it yourself or you can round it yourself. Okay. No. Okay, so any other questions? All right, so you guys are good to work there.